This week we are diving right into the last kind of revolution following the Renaissance. We've talked about changes in the ways people began to think about the world with humanism from the Renaissance, the ways people interacted with the rest of the world with exploration, and just last week, changing thoughts about religion and what religion was and what people can believe, and religious freedom, kind of after that 30 Years' War as a result of Reformation, Counter-Reformation. And with this one, it's a kind of a combination of two different time periods, the Scientific Revolution and the Enlightenment. And these two are all about the ways that people think and the ways they arrive to new ideas, science and politics especially. So with that, here we go, Scientific Revolution. And this was a new way of thinking about the natural world and society that relied on experiments and new science. You have those translated works brought back from Greece and Egypt and the Muslim world after the Crusades, and they're being translated. So all of these ideas, all of this literature about math and science and how the universe is set up are translated for people to now research. Because prior to this, during medieval Europe, there was the reliance on religion for the ways things worked. Everything cycled back to the church and what the Bible had to say as truth. And people accepted that. Whatever ideas were upheld by the church, that was what people accepted as fact. It was a focus on what you could see and what you could feel. Not so much like the things that you're thinking, but I can very clearly see that this causes this, so this must be true. Kind of with the addition that people believed and supported alchemy and astrology, these ideas that magic is possible and believable. Belief in witches and wizards and sorcerers continued, although it transitioned in history from someone that people trusted and used for protection to someone to be feared, as we've seen with witchcraft trials all over, or witch trials all over Europe and into America as well. But the reasons for these changes really traces back to humanism, back to the Renaissance, where scholars are starting to challenge the church and those traditional authorities. They're trying to figure out ways to know what is true and verify that with observations or research or facts. And so you have theories being made and procedures being created to test those ideas, using evidence and experiments to figure out how the world works. And this was helped by exploration. More food and more money was available to pay thinkers, so a scientist, a political scientist, a thinker can spend their day doing these experiments if they're being paid by someone. And what a lot of people consider to be the turning point or the very beginning point of the scientific revolution is the geocentric versus heliocentric theories. And the geocentric theory, as you can see from the diagram here, has the Earth in the center. It said the Earth does not move and everything else rotates around it. At the farthest sphere are fixed stars, they don't move, and heaven is beyond that. It was originally created by Aristotle and then expanded on by Ptolemy, and this is what both the church taught, this theory and this idea that God deliberately placed the Earth at the center and it was meant to be unmoving, and that's what everybody believed. Copernicus was the first to propose a heliocentric theory, where now the Earth revolves around the sun. Now the sun is the unmoving object that everything else rotates around. But he was afraid of persecution from the church, being Catholic Christian himself, and so he waited until his deathbed to publish his theory on the revolutions of the heavenly bodies. And this was kind of a work in progress, but it laid out this new idea. He didn't receive any problems for it because he died soon afterwards. And it wasn't until later when Galileo picked that theory up and expanded on it even more. Galileo was focused very much on astronomy, figuring out what the planets were like, what the universe was set up like, how does it move, what is its structure. And so he made some pretty cool discoveries. 3 of the ones here from the Starry Messenger said that Jupiter has 4 moons and the sun has dark spots, things that which we know that the sun has dark spots because our science has gotten so advanced that we can actually photograph those things. And we know that Jupiter has far more than 4 moons because we can actually send out probes and satellites to go check those out. He also proposed that these heavenly objects, like stars, were not just pure orbs of light. They were actually made of something, some material. And that's all in addition to kind of re-proposing this heliocentric theory, re-proposing that the sun is at the center of the universe and the earth turns around that. And it was that, especially that one theory, that put him at odds with the Catholic Church. These are a few of the verses that the church used to kind of contradict what Galileo was saying that the world is stable, it can't move. Therefore, this idea that the earth rotates is insane. It can't be right because it isn't supported by scripture. So they ordered Galileo to abandon his ideas because they were threatening to the religious ideas of the way that the world worked. And so you have this very clear faith versus science debate that happens. You have Cardinal Bellarmine argues on the side of the church that truth is in the Holy Scriptures, and the literal truth about the world is written down. And if something is proved false, then that means everything can be shaken. And Galileo said that the church should interpret scripture based upon what is known by science, and that if he is wrong, then the Bible will prove him wrong. And this goes back and forth. Galileo eventually does get excommunicated by the church for refusing to give up his ideas, but this is a very vivid instance of faith and science coming to a breaking point. This didn't stop people from continuing to experiment and continue to make new ideas, and there was many different breakthroughs and ideas that we've continued to explore today. You have advancements in medicine, and especially human anatomy. People are learning and making diagrams and drawing what the human figure looks like, where the muscles are located, veins, tissues even. You have the study of cardiology, so how the heart works, how blood pumps through the body and through the veins. Mathematics and technology, like more microscopes and telescopes being created that continue to help with all of these ideas as they continue to grow and people continue to use them. And the central piece in all of this is upon the basis of reason. Scientists believe that reason was the main source of all knowledge. Reason is what you use when you're coming up to some problem, some situation. If you say, My phone is working really slowly. I wonder why. Then you could go through, you could check, well, is my battery low? Do I have too many tabs open? Do I have a program running in the back? Do I have a virus? And you would go through and you would check all these things, reason through them to figure out what was wrong. And then you would try, well, I do have 20% left of my battery. Let's try plugging it in, see if that helps. Or, it has been a while since I've restarted my phone. Maybe I should try that and see how that works. And that's the scientific method. This step-by-step process of figuring out information and coming to a conclusion. Francis Bacon was the one to explain the scientific method. He's the one who's famously quoted as "knowledge is power," Francis Bacon. But you use reason to collect and use new information. And here with the scientific method, you use inductive reasoning. You start with a question or address a problem and then start to research it. And as you research it, you come up with a hypothesis, an idea of what you think is wrong. But the whole point is to think without your own opinion, to think without any previous idea of what should happen or what will happen. You gain knowledge as you continue without any connection to expectations. And this is what allowed people to learn even more. They're thinking about the world separate from religion, and so they're using these repeated experiments and repeated thinking as a way to learn more, as a way to explore the world more and think about it in this very, very systematic way.